if it is has a chiral center and the substrate is optically active, then comes is stereochemistry. So in case of stereochemistry, the transition state of SN2 reaction has a planar arrangement of carbon atom and the remaining three groups. So the occurs with inversion of chiral center called Walden inversion. I think one of you has said about the Walden inversion can be expected in the SN2 reaction in the last class, right?
Yes.
Yes, so Walden inversion, if you want to notice this kind of Walden inversion, then the substrate needs to be taken is an optically active substrate. If it is not optically active substrate, like methyl bromide, if the nucleophile prefers to attack over the methyl bromide, then you can expect only a methanol. So no stereochemistry with respect to the formed methanol. But instead of having an optically active substrate, if you are having an optically active substrate, then comes is like what type of inversion one can expect. In this case, the CH, H, and CH2, right? So this will act as a nucleophile, and nucleophile prefers to attack over the in tetrahedral geometry. The carbon is in tetrahedral geometry, and so during this reaction, the nucleophile prefers to attack over the carbon. Wait. So this is not optically active substrate. Do you think this is optically active substrate?
No, sir, it's optically inactive.
This is optically inactive. Let us assume. So in the previous example, we have only the methyl bromide. Now the one of the H has been replaced by one methyl. So this is an example corresponds to ethyl bromide. In this case, the carbon has two hydrogen bond and one methyl group, along with that one leaving group of Br. In this case, the nucleophile, the red dot represents the nucleophile, and this particular portion will represents to the substrate. This is the leaving group, and this is the carbon, and wherein you have a substituents on the carbon. In the SN2 fashion, the nucleophile prefers to attack from the front side or back side.
Backside.
Backside.
Yes. So why it is prefers to attack from the back side? Why not from the front side of the where the
Because
leaving group lies to leave salt? So now in this case, let us assume this is the nucleophile, and this is the carbon, and this is the leaving group. Now there are two openings where the nucleophile can approach, right? One is from the back side with respect to the leaving group's leaves out, or from the same side of the leaving group's leaves out. Also, there is a possibility to attack over the carbon. Why it prefers to attack from the back side rather than from the front side attack? Any reason?
Steric hindrance.
Steric hindrance, right? Okay, then anything else? Br is bulky group, of course, steric hindrance, fine. Next. What charge usually the nucleophile prefers to have it?
Negative.
Negative.
Negative. And suppose you have an electronegative, the carbon is more electronegative, or the Br is electronegative?
Bromine.
Okay.
Br.
So bromine is electronegative, right? So now what type of charge one can notice over the carbon as well as on the bromine atom?
Partial positive and negative
Yes,
charge.
partial positive charge over here and partial
Positive
negative charge. What it represents
negative.
generally? Means electron density is more over carbon, or electron density is more over bromine?
In bromine, sir.
Yes, electron density will be more over the bromine system, right? So now let us assume the electron cloud is more towards this, and you have a nucleophile. It is also has an electron density. The both are negatively charged. Do you feel that the negatively charged can easily approach from this side to attack
No,
over this particular carbon?
No,
Because
sir.
you know that like
No, sir.
charges,
There will be electrostatic.
Repel each other.
yeah, so like charges generally repel each other and unlike charges attract each other, right? So in this case, as it is negatively charged, and this is also to prefers some partial negative charge because of the electronegative difference between the carbon and the bromine, this prefers not to prefer to attack the carbon from the same side of the leaving group leaves out. Instead, the backside attack here, there is no steric hindrance or electron repulsion caused by the any of the substituent which is present over the carbon, and it can easily approach the carbon side, the carbon which is carrying the leaving group from the back side rather than from the front side. During the approaching of this nucleophile over the carbon from the backside attack, you need to have attain a transition state. In the transition state, if you look into this transition state, the electron density is slightly less over the carbon, and electron density will be more over the nucleophile, and electron density will be more over the BR system. That's why the partial negative charge happens over the nucleophile, and partial negative charge do happen over the bromine atom. This is a planar transition state. And in this case, there is a new bond establishment between the carbon and the oxygen, and the bond breakage between the C and Br system. Once this state, transition state, is over and it overcomes from the bond breakage and bond formation process, then only you can expect the tetrahedral geometry, and which corresponds to the alcohol. Here, you are converting the alkyl bromide, that is of primary alkyl bromide we have taken. In the previous example, you have taken an example of this methyl bromide. And suppose if you have a methyl substituent here, that is ethyl bromide, then you can expect one of the system over ethyl. Right. So rest will be just inversion of configuration. But as it is not optically active, you cannot distinguish the formed product. Let us look into the optically active substrate. So optically active substrate, this is whether it is optically active.
Yes, sir.
Here the carbon has CH3 and the C2, CH2, CH3. This is also a different group, and CH3 different group, and then H is also different. And yeah, so the carbon now, the name of this substrate, CH3, CH. In the second position, you have an iodo group, and CH2, CH3. Name of this substrate? 1, 2, 3, 4. 4 carbons. The second carbon.
2-iodobutane.
Yes, 2-iodobutane. So the 2-iodobutane is the substrate, and this is actually optically active and chirality because of this carbon has a chiral center. And this substrate now acts as an optically active substrate. And SH minus you are using as a nucleophile. The SH is now in this case to the SN2 mechanism. In the SN2 mechanism, the SH minus prefers to attack from the backside and attack over the carbon, and simultaneously the Ci bond breakage, and you will get a CSH form thiol. The bond to the nucleophile in the product is always on the opposite side relative to the bond to the leaving group in the starting material. So prefers to attack from the backside, and bond formation happens between the carbon and the sulfur, and the bond breakage is taken place between the carbon and the iodo. This is in case of SN2. And during this optically active substrates, if you're having, then the configuration will change. Suppose if you have an R configured starting material, then as it is prefers to attack from the backside, there is an inversion of configuration. So the end product of thiol generally has an S configuration. Suppose if you start with an optically active S, then you will get R. So the product is having inversion of configuration in case of optically active substrates. Suppose if you are taking an optically active alkyl halide as a substrate and you're trying to perform an SN2 reaction, then you can expect the inversion of configuration because of the nucleophile prefers to attack from the opposite side to the bond breakage between the carbon and halide system. In case of, okay, now it's clear with SN2.
Yes, sir.
Yes,
Okay.
sir.
So
Yes, sir.
some of the points you need to remember that what type of substrate, what type of alkyl halides, and whether it is rate of reaction is dependent on both the substrate and the concentration of the nucleophile. Then transition state formation is the intermediate step, and during the transition state, the carbon has a penta coordination state, and a partial negative charge occurs on the nucleophile as well as on the leaving group. This is in planar transition state formation, and nucleophile prefers to attack from the opposite side from the where the leaving group leaves out. And you will, if an optically active substrate if you are taking, then inversion